Welcome students to the ACT Practice Test Part 6, and I believe that congratulations is definitely in order for those that have made it this far. So if you've listened to the 5 videos and you're on number 6, congratulations, way to stick with it. And if you can just take, I don't know, 5, 6, 8, 10, 12 thoughts, something from this entire thing, it will raise your ACT score somewhat and hopefully significantly. And so hopefully these videos have been a help to you. Let's go ahead and get started with number 51. Part 6 will cover problems 51 to 60, and then we'll be finished with the entire ACT practice test. Let's take a look at number 51. Circles with centers A, B, and C, and that's important, by the way, that tells you they're right in the center of the circle, respectively, are mutually tangent. Now that's important too. What that means is these circles are intersecting in just one place right there. They're just barely touching on the edge. That's what it means when it says these circles are tangent. So these circles are not overlapping at all, just a little bit. They're not doing that, okay? That's what tangent means. And they have radii, which is plural for radius. They have radii of lengths A, B, and C respectively. The lengths of AB, BC, and AC are 13 inches, 15 inches, and 26 inches respectively. I think we should pause and write that off to the side so we can get a little order here. AB equals 13, BC equals 15, and AC equals 26. Now on the ACT test, you might not have the luxury of doing something like this, but right now I'm trying to teach you how to solve this problem and how to think in a certain way. So I'm going to take my time and help you here. Now, what is the value of A plus B plus C? Now I'm going to be honest with you. When you're looking for the value of A plus B plus C, sometimes you're trying to think, how can I find A? And you're studying, or how can I find B, or how can I find C? And you're studying the problem looking. And sometimes you have to just step back and just list as much information as you know, and then use equations or other mathematical knowledge you've gained through the years. For example, you should know by now, if you were to draw a circle and draw a radius, and know that, of course mine went too long there, but draw a radius like this. If you knew that's a length of 5, you know that every other radius that you draw is going to have a length of 5. You know that. You learned that probably in elementary school. So if from here to here is B, then I know from here to here is also B. That should make sense. And if, let me change colors of ink. If I know from here to here is A, then I know from here to here is also A because it's the same radius. So this has a length of A. And if I know from here to here is C, then I know from here to here is also C because they're the same radius. So I can put a C. Now how does that help? Come on, think about it. Do you see this whole length right here? BA, that entire length. What is the length of BA? 13. So could I not say that A plus B equals 13? I mean, from here to here is A, from here to here is B, so A plus B is that whole segment, which would be 13. Could I not also say, let's take a look at BC, from B all the way to C right here. Could I not say B plus C equals that whole length, which is 15? So I could say that little b plus little c equals 15. And then could I not also say that from here to here is C, and then from here to here is A? So if I take A plus C, that will give me the entire length of AC, and the entire length of AC is 26, so I can put a 26. See how I did that? Let's review for a second. We're not in a hurry here. Look, first of all, you've got to think outside the box and realize the radii of a circle, of one circle, are all going to be congruent. Sorry, excuse me. And number two, you've got to realize that sometimes when they ask you to find A plus B plus C, you're not going to be able to find those values right off the bat. You got to write down everything you know. And then brainstorm and write down everything you see here, and now I'm looking pretty good. Now, before I get into finishing this problem, let me say this to you. It is very important that you suck up all of the easy problems and do them as fast as, kind of like a vacuum cleaner, just suck them up and do as many easy problems as you can, as quickly as you can, without missing them, of course, so that you have more time for these more difficult problems. Now, there's many ways to solve this system. We have three unknowns, A, B, and C. And when you have three unknowns, you should know from Algebra 2, you need three equations. So I'm going to use substitution. I mean, right away I'm saying to myself, okay, it really doesn't matter, by the way, students, how you do this. I just feel like getting A by itself, so that's what I'm going to do. So I'm going to move B over here like that, okay? And if I do that, if I take B right here, and I move B over here, which looks more like more of a job than I thought, and when I bring B over, when I bring B over, it becomes negative. So now I have A equals 13 minus B. Now, why would I do that? Well, come on down here and look. See this A right here? If A equals 13 minus B, then where this A is right here, I can now put 13 minus B. That's for A. Then bring down your plus C. Then bring down your 26. Now, why would I do that? Well, let me show you why. If I look what I have now. I have an equation that has B and C, and I have an equation right here that has B and C. That helps a lot. I have two equations with the same two unknowns, and that's really, really helpful. So now that let's review. I got A by itself, and by the way, you did not have to do that. You could have got B by itself or C by itself, it doesn't matter. But I isolated the A, then I came down here and made a substitution for A because A equals 13 minus B. Then I'm going to simplify this equation. So I'm going to make this equation a little easier to see. I'm going to bring the 13 over, and when I do, it's going to become a negative 13. So it's a positive 13. And I'm going to bring this positive 13 over, and when I bring it over, it becomes a negative 13. So now I have negative B plus C equals 13, because 26 minus 13 would be 13. So now this equation here is really gone, to be honest with you. I don't need this equation anymore. I've simplified it, and so I can very quickly get rid of that. So look at my equations I have now. I hope this is making sense. It really should from Algebra 2. I mean, all that I have to do now is take my two equations that have the same two unknowns, B and C, and look at this. They're ready to just eliminate right now. I mean, if I add these two, you should know this from Algebra 2, linear combination. If I add these two equations together, these cancel. C plus C is 2C. 15 plus 13 would be 28. Divide both sides by 2, and C equals 14. Well, look, if C equals 14, come up here. Do you see this A plus C? What can you put for C right here? Can you not put 14 right here? So now I have A plus 14, right? Bring the 14 over and make it a negative 14. So now A equals 26 minus 14, 12. Well, now you know what A equals. So see this A right here? What can you put for A? You can put a 12 right here, can you not? Sure you can. And then let me get a little room here. Well, I don't want to erase all this, I guess. So let's do it. Let's get some room doing this. Let's pull it up here and get a little more room. Now, look at this. See this 13? Bring this 13 over to the other side. Bring it over. And when you bring that over, it's a positive 13. So when you bring it over, it becomes a negative 13. So we got rid of our positive 13. So 12 minus 13 is negative 1 equals, and B is negative B. So negative 1 equals negative B. Divide both sides by a negative 1, and 1 equals B. So you did it. And now they're asking you, what is the value of A plus B plus C? So A plus B plus C. Well, A is 12, B is 1, C is 14. I'm getting 27. 12 plus 1 is 13, plus 14 is 27, okay? So they wanted you to understand what tangent circles means. It means they're intersecting in one place on the edge of their circles. They wanted to test you on your remembering that all radii are congruent, and they wanted you to be able to list out a system of equations and then solve, which is algebra 2. So a really, really good problem. Number 52. Which of the following sets of 3 lengths in decimeters are the side lengths of an obtuse triangle? Now, this goes back to a geometry principle that hopefully you remember. And it just simply means this. I'm going to write it kind of in my own language here. If you take the longer side, and that's supposed to be 2 words, I just kind of crammed it together, and you square it, and on the other side you take a shorter side and square it plus a shorter side and square it. Now, one thing I shouldn't have done is I should not have put an equal sign here. Let me erase that. Now let's review. You should have learned this in geometry. Whenever you're given 3 possible lengths of a triangle, you can always take the shorter side, the 2 shorter sides, square them and add them together, and then compare that to the longer side squared, and you're either going to get out the left side will be greater than the right side, or the left side will be smaller than the right side, or the left side will be equal to the right side. Now you need to know all of this stuff here, okay? I'm telling you, when you get out that the left side is greater than the right side like this, that means you have an acute triangle. You should remember this from geometry. If not, write this down. If you get out that this left side right here is greater than the right side, then that means you have an acute triangle. If you get out that this left side is less than the right side, then that means you have an obtuse triangle, which is what they want you to try to find over here. What if you get out an equal sign where this side equals this side? Then that means you have a right triangle. Now you need to write all that down. That's what we're going to do now. So we can do this so quickly, students. Start with letter F. Here's your shorter side, longer side. So 4 times 4 is 16. 4 times 4 is 16. 5 times 5 is 25. Add these two together. 32 is greater than 25. Nope, no good. Remember, when the left side is greater than the right side, that means you have an acute triangle. And we're trying to find which one of these sets are the lengths of an obtuse triangle. So we want to get out a left side that is less than the right side. That's what we're trying to get, okay? So that did not work. Let's quickly try the other one. Let me increase my eraser here. There we go. Okay, smaller side would be 5 squared, that's 25, and 12 squared is 144, and 13 times 13 is 169. And so here you would get out 106. If you add these two together, you get 169 equals 169. Nope, it's not going to work. You can do this pretty quickly once you know what you're doing. I would say less than a minute. 6 times 6 is 36, 8 times 8 is 64, 10 times 10 is 100. Add these two together and we get 100 equals 100. Okay, now I hope I'm not making any little mistakes. I don't think I am. 7. Now we're going to look at letter J right here. 7 times 7 is 49. That's one of your smaller sides. 10 times 10 is 100. That's one of your smaller sides. Your largest side or longer side is 12. 12 times 12 is 144. Add them together and you get 149 is greater than 144. So hopefully it's the last one. Let's see. 8 times 8 is 64. 11 times 11 is 121, and 16 times 16, I actually do not have my calculator with me. That would be 96, 256. If you add these two together, you get 185. I should not have put an equal sign there. 185 is less than 256, and that's what you wanted. Now, it's a shame it's the last letter, okay? But that's how you do this problem, okay? And they're testing your ability. Again, do you remember geometrical principles that you learned in geometry? And so here it is again. Whenever you're given three lengths of a triangle, you can tell whether it's acute, obtuse, or right by taking the two shortest sides, squaring them and adding them together, and then taking the longer side and squaring it, and then comparing your two sides. If this side over here, the sum of the two shorter sides squared, if this side is greater than this side, then it's an acute triangle. If it's less than, then it's an obtuse triangle. And if these two sides are equal, then you have a right triangle. Okay, so this is something you need to know. All right, moving on to number 53. This is going to be pretty much a trigonometry problem, so some of you might not have had this yet. So understand that that can happen, and just do the best you can to follow along. Angle A measures 9 pi radians. Now usually in all textbooks it's written like this. I'm not sure why they put the pi out front, but this 9 over 2 pi is the same thing as 9 pi over 2. Angle A measures 9 pi over 2 radians from its initial side to its terminal side. Angle B has the same initial side and terminal side as angle A. Which of the following measures could be angle B? Now here are some things that I notice, okay? Watch carefully. First of all, I notice that all of my answers are in degrees. So in case you have forgotten how to convert radians to degrees, let me remind you, you always multiply radians by 180 over pi. You need to know that for the test. I hope as you're listening to these videos that you're making a list of things to study. That's the whole idea. It's not just me teaching you how to do a certain problem, because you know the test you're going to take is going to have different problems. I'm trying to give you objectives, thoughts, principles to go home and study. Now, if we take 9 pi over 2 times 180 over pi, we can do some cross canceling. 2 goes into 2 and 2 goes into 180. And then your pi's would cancel. And so you're basically left with 9 times 90 and 1 times 1. Now 9 times 90 is 810 degrees, and 1 times 1 is 1. So we're going to call it 810 degrees. So instead of having 9 pi over 2, we really have 810 degrees. Now, you need to know how to do that. So write that down, make notes somewhere. That's something you need to know how to do. Now, when you see 810 degrees, what is that? Well, let me show you, okay? This is called your initial side because it's where we're going to start. This is like a coordinate plane, your y-axis, your x-axis. Now, we're going to go around one time. That's 360. But we want to go 810 degrees. So we're going to go around again. That's 360 more. So that's 720. And then we're going to go 90 more degrees. There. Now that's 810. Think about it. I went around once. That's 360. I went around again. That's 360 more. 360 plus 360 is 720 plus 90 more is 810. So let me get a different color of ink and show you something. So where did I start this angle at? Right there. So this is called the initial side. Where did I end my 810 degrees? I ended right here, right? So what other angle, this is so obvious, what other angle could you have that would start here on this black line and rotate up to this black line here? Well, wouldn't it be 90 degrees? I mean, 90 degrees would start in the same place and 90 degrees would end in the same place. Yeah, but Mr. Earhart, you didn't go around as many times. That's not what the question says. It says angle B has the same starting side, initial side, and the same ending side, terminal side, as angle A. So 90 degrees would start here and it would go here. So which of these angles could be angle B, has the same starting side, has the same ending side? 90 degrees. Definitely 90 degrees. Now that's a review of radians and degrees. And by the way, if you ever have to convert degrees to radians, like if you wanted to convert 90 degrees over to radians, instead of multiplying by 180 over pi, you multiply by pi over 180, the reciprocal. So keep that in mind in case you have to do that on the ACT test, okay? So if you're converting from degrees to radians, multiply by pi over 180. If you're converting from radians to degrees, it's 180 over pi. Memorize that, write it down. Back the video up, listen to it again, write it down. You need to know about initial sides and terminal sides, okay? What that means, it's where an angle starts and where it ends. Okay, and that's what this problem is testing you on. Number 54. This will be a very interesting problem. A polynomial in X has m non-zero terms. Another polynomial in X has n non-zero terms. Now notice that the m non-zero term polynomial has less non-zero terms. M is less than n. And these polynomials are multiplied, and all like terms are combined. The resulting polynomial in X has a maximum of how many non-zero terms? Wow. I mean, even to me who's had a lot of math, that sounds somewhat like Greek. Okay? And so let's see if we can't break this down like we did a couple problems ago when we had all of those radii, this problem right here. We just simply wrote down what we knew and then started writing down more information that we knew, then started writing equations and going from there. Now here's what we know. We know that we have a polynomial that has m non-zero terms. Let's just make it up. Let's say that the polynomial is, I don't know, x squared. Now let's just say the polynomial is x minus 5. There we go. Now, this polynomial has m non-zero terms. I have a question for you. How many non-zero terms do you see? I see one term. I see two terms. Got it? One term, two terms. So in this polynomial, m equals 2. Fair enough? I just made that up. It's a polynomial that has m non-zero terms. It has two non-zero terms. Now, then we have a polynomial that has n non-zero terms. Now, notice here though that m has to be less than n. So if this expression here has two terms, then I better make my next one have more than that. So we're just going to say three terms. There we go. X squared plus x plus 4. That's three terms. 1, 2, 3. So there I have a polynomial expression with n non-zero terms. And how many non-zero terms do I have? 3. So n equals 3. I'm just making these up, and that works because m has to be less than n, and notice m is 2 and n is 3, so 2 is less than 3. So we're good. Now, these polynomials are multiplied. So let me grab this, yank this over here. Now, we're going to multiply these two polynomials, okay? And all like terms are combined. The resulting polynomial in X has a maximum of how many non-zero terms? Now, think about it. If I were to multiply these two polynomials together, you should know by now from Algebra 1 and Algebra 2, I would take x times this, x times this, x times this, and I would get x cubed, x squared, 4x. X times x squared is x cubed, x times x is x squared, x times 4 is 4x. Then you take your negative 5 and you multiply it through the parentheses. So if I do that correctly, I'm going to have negative 5x squared, negative 5x, negative 20. Negative 5 times x squared, negative 5 times x, negative 5 times 4. Now, I know what you're saying. Mr. Earhart, we have like terms, we can put them together. I know that, but please read the question carefully. The resulting polynomial, after you've multiplied, these polynomials are multiplied, and all like terms are combined. The resulting polynomial, this is my resulting polynomial right here, in X, notice it's all in X, I have all X's here, has a maximum of how many non-zero terms? Well, if you're going to put your terms together, like put your x squares together like you normally were taught to do, that's really not going to help you here because they want to know the maximum possibilities. Like pretend for a second this was x to the 5th, and pretend after all of our multiplying there were no like terms. If there were no like terms, just pretend for a second there were no like terms. How many terms do you have here? 1, 2, 3, 4, 5, 6. So if there are no like terms, what is the maximum amount of non-zero terms? 6. But hold it. That's just for a problem we made up here. So I'm noticing something here. How many terms did I have here? Remember? 2. How many terms did I have over here? 3, remember? Well, doesn't it make sense you would have 6 terms at the most down here? Because you're going to multiply this how many times? 1, 2, 3. That gives you out 3 terms. And then you're going to multiply this how many times? 1, 2, 3. So that would give you how many more terms? 3 terms. So you would have 6 total terms. In other words, however many terms you have here, and however many terms you have here, if you multiply them together, you will always get out the maximum number of terms. So if I have 2 terms here and 3 terms here, the maximum number of terms I'll get out is 6. So what does 2 stand for? M. What does 3 stand for? N. What did I just say that you could do to the 2 and the 3 to get out your possible maximum non-zero terms? Multiply them together. So it seems like to me if you take M times N, you will always get out the maximum number of zeros. And that is, I'm not sure why I didn't list out the answers on this for you, and I apologize. Let me quickly glance in the book and write those down for you. That will happen sometimes with my forgetfulness. The answers were F, N, G, M plus N over 2, H, M plus N, J, M, N divided by 2, and then K, M, N. So the answer would be K, M, N. Now, just one more quick thought to make you think, and it's so good, of course, to make you think. You might say, well, Mr. Earhart, you just gave us one example. What if that's not true? Well, just look at this. What if I had 3 terms? I don't know, just 3 terms. X, X, and X. It doesn't matter. Times X, X, and X over here. Think about it. How many terms do I have here? 3. How many terms do I have here? 3. If I multiply those together, I will get out at the most how many terms? 9. And that makes sense. You would take this X and multiply it 3 times. That gives you 3 terms. Then you would take this term and multiply it 3 times. 1, 2, 3. That give you 3 more terms. Then you would take this X and multiply it 3 times. That would give you 3 more terms. 3, 3, and 3. That would be 9. 3 plus 3 plus 3. And so it is how it works. However many terms you have in one polynomial and how many terms in the other, multiply that together and you will get out the possible maximum amount of non-zero terms. Okay, so they're just testing your understanding here of polynomial multiplication. And that's basically it, just understanding the characteristics of polynomial multiplication. Okay, moving on to number 55. Now, Hannah is building a fence along 3 sides of a rectangle. She's leaving one of the short sides unfenced. The fence has a post at each corner. The rectangle is 30 feet by 48 feet. Now, for me, I'm a huge visual learner, and so I'm going to get a quick picture of this, okay? Here we go, and there we go. All right, so she's only fencing in 3 sides, so I'm going to leave this side here completely open. All right, now it says it's 48 by 30 feet, so this is going to be 48 feet, this is going to be 48 feet, and this is going to be 30 feet. Now let's continue and read on. As shown in the figure below, adjacent posts of the fence are set every 6 feet. So every 6 feet there are posts, and there are 12 wooden slats between each pair of posts. How many wooden slats will Hannah use for the entire fence? Now, if you want to get really picky and say, wait, how wide are the posts, and subtract that out, notice they don't give you any information on that. And also notice when they say 6 feet, they go from the middle of one post to the middle of the other post. So when you notice those 2 things, they're actually not making this problem as difficult as they could have made it. They just want you simply to realize that you're going to take this side and divide it up into every 6 feet, because every 6 feet you have how many wooden slats? 12. Every 6 feet you have 12 wooden slats. Now the fast way to do this is to simply take 48 and divide it by 6, take 48 and divide it by 6, take 30 and divide it by 6, and you know how many sets of 12 slats you have, and you'll get the answer very quickly, 252. And that's fine, but for those who are a little slower, I'm trying to help them, okay? Now every 6 feet we're going to divide this 48 up, and that's going to be about 7 lines, I believe. I hope I'm right. Let's see if that's right. We should have 8 of these gaps. Let's see. 1, 2, 3, 4, 5, 6, 7. So we need one more gap here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there we go. So every one of these gaps represents 6 feet. If you counted by 6, you would get 48 all the way across. Same thing over here. So here we go. So we have the same thing here. We have 8 gaps. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now going across this way, we're dividing 30 up every 6 feet. Why every 6 feet? Again, right here, students. Every 6 feet, there are 12 wooden slats. Every 6 feet, there are 12 wooden slats. So with that in mind, we're going to have 1, 2, 3. There we go, 6 spaces. 1, 2, 3, 4, 5, 6. Okay, so every single one of these spaces has 12 wooden slats. So we have 12 wooden slats here, 12 wooden slats here, 12 wooden slats here, all the way around. So I would have 1, 2, I would have 8 here, and 8 here, and I would have 6 here. So 8 plus 8 is 16, plus 6 more would be 22. All right, let's see if that's right. Is that right? Yes, 22. Now, one quick thing, students, I did pause the video because I've worked all these problems out ahead of time, and I was kind of looking here. I was like, this is not making sense, and it's kind of funny. Mathematicians are known to make little mistakes, and you guys probably already saw what the mistake was. We should not have 6 gaps up here. If you take 30 and divide it up into segments of 6 feet, you would actually have 5 of these. So I apologize. No one likes to make mistakes, and it's embarrassing, but I'm not going to start the entire video over. So let's go ahead and spread this out. There we go. Let me explain what I did there. Remember how I took 48 and divided it by 6 and I got 8 spaces? Well, if you take 30 and divide it by 6, you don't get 6, you get 5. And that's just a little mathematical mistake that I made. And so I was I paused the video. I was like, this isn't making sense. And now I see where my little mistake was, and I apologize. You would have 5 spaces. 1, 2, 3, 4, 5. So you have 8 spaces going up here. You have 8 spaces going up here, and you have 5 going across. So the total amount of spaces that you have is 21. Now please don't forget, every space represents how many wooden slats? 12. You got 12 here, 12 here, 12 here, 12 here, 12 here, 12 here. So you have 21 spaces. Each one is worth 12. So if you do your multiplication, you're going to get this would be a 1 here. You will get 252. Okay, 252. So I apologize again for that little mistake there. I know that can be confusing to a lot of you, but that is a good visual way of doing the problem. Now for others of you, and again, I'm doing this in video form so you can back it up and watch it again and again if you need to, but others of you just might say, this is easy. I got 48 for one side, divide that by 6, and that would give me 8. The other side's 48. Divide that up into segments of 6 feet. That's 8 segments. Then take my 30, divide that by 6. I would get 5. Add those up, I'd get 21, and then multiply it by 12 because each one of those spaces has 12 wooden slats. To be honest, that's how I would have done it. I would have wanted a little picture real quick to glance at it, then I would have done it this way. But either way, here's what they're testing you on. They're testing your ability again to know what to do in a situation, problem solving, thinking skills. Do you know how to set up a visual and look at it? Do you know how to divide numbers and to realize I'm taking a certain length of fence posts and dividing it up into segments of 6 feet? Why would you do that? Because every 6 feet has 12 wooden slats. Okay, that is what they're trying to test you on here. Okay, so just a reasoning problem. Number 56. Now here they're testing your ability to understand graphing systems. Well, a couple of things. First of all, they're testing your ability to understand how to graph or solve inequality systems, which is what we have here. And I think they also want to know if you know how to take something like this and this and kind of break it down. For example, when you see a compound inequality like this, I've always taught my students to go like this. Just say x is greater than or equal to 10 and x is less than or equal to 40. I break that up into two easy to see expressions. See this expression right here? This compound inequality, I always tell my students, hey, break that up into this right here. Y is greater than or equal to 0, and y is less than or equal to 30. Because that's what it says here. X is greater than 10, so greater than 10. X is less than 40, less than 40. Y is greater than 0, greater than 0. Y is less than 30, y is less than 30. So first of all, right off the bat, you're looking for a graph that's going to have two vertical lines, one going through the x-axis at 10 and one going through the x-axis at 40. Okay? Now again, guys, it's not my job to teach you Algebra 2. I'm just showing you how to do these quickly and what they want you to do. This is something you should have learned in Algebra 1 and Algebra 2. Okay? It really is. So we're looking for a graph. I'm going to go ahead and just draw it here and we'll try to match it up. If I was taking the ACT test, I would very quickly on a separate sheet of paper start drawing this graph, and by process of elimination I would start crossing these off. For example, I know that I want to have a vertical line going through 10. That's not a very good vertical line. I know I want to have a vertical line going through 10 and a vertical line going through 40 like this, and there we go. And then I know that I would shade x is greater than 10, so I know I would shade this way, and x is less than 40, so I know I would shade this way. Now that should look familiar. Well, right away, look at this. Do you see your vertical line here? And do you see your vertical line here? They didn't shade between those two lines right here at all. And I'm saying here's your y-axis, here's your x-axis. So right there, do you see how I'm using process of elimination? So right now, I'm going to be able to take my pen here and cross that off. That's gone. That's not an option. That is not an option, okay? Now, let's continue on. Look at your y's here. I know I'm going to have a line going through the y-axis at 0, like this, and a line going through the y-axis at 30, like this, and y is greater than 0, so I know I'm going to shade up this way, and I know I'm going to shade down this way. So far I know I should have somewhat of a box. I know I'm going to shade this way, this way, this way, and this way. So now I'm looking. All of these fit that description. So far everything is shaded. No, this one doesn't. My fault. Look at J. Do you see how J came outside the box right here and shaded down here? Do you see that? So again, process of elimination is a huge thing in this in taking this test. You cannot go outside this box. This line is down, this line is up, this line says shade to the right, this one says shade to the left. So I know this one is now no good. So I'm left with three options. Now, let's take a look at this problem here. I know that I'm going to go through the y-axis at 45. So I know somewhere up here I'm going to have my linear equation coming down, and we can see that right here. See this one coming down, this one coming down, and this one coming down. Do you see that? So I skipped this one here because it had a fraction, and I'm trying to do this as fast as I can, so I'm graphing all the easy ones first, hoping by process of elimination I can finish this thing off. So here's an easy one. So whenever y is by itself, I know my constant term is my y-intercept. So I know the line is going to be up here, and because my slope is negative, I know the line is going to go downward like this. Okay, and actually I want to be very consistent with my graph, so I'm going to go ahead and make sure this is red. So I know my line is going to come down and do something like that. Now that's not perfect, you understand, but it's decent. All right, it's decent. Now notice also it says what? Y is less than. Y is less than. And whenever y is all by itself, if it says less than, you know that you can just shade in whatever direction this says. And it says y is less than. So I know that this line here I just drew is going to shade down this direction. So now look at your graphs and see these lines that are going downward right here. See those lines that are going downward? You should be shading below that line this way. And this one's not. Look, this one's not. Here's the line. Here's the line right here. And it's going upward. You're shading above the line. That's impossible. And look at this one, same thing. Here's your slanted line going downward, and look, they shaded above the line. That's impossible. You have to shade below this line, so that's no good. So right away, by using the process of elimination, we don't even have to graph this last line or this last linear inequality. We know G is the answer. Okay? Now, they were teaching you, or they were testing you, multiple things here. First of all, they're testing your ability to graph linear inequalities. That's important. Secondly, they're testing your ability to go through, to break down compound inequalities like these into simple inequalities and graph those in shade. And they wanted you to see if you could just use common sense and reasoning as you shaded, and use process of elimination and quickly eliminate some of these until you're left with one that just makes sense, that's going to fit this over here. A very good problem, very good problem. All right, number 57. In the diagram below, chord EF is parallel to AB. So this line here is parallel to this line here. The length of EF is 10 inches like it says right here, and the length of AB is 14 inches like it says right there. What is the distance in inches from C, the center of the circle, to D? So we want to know this length right here. I want to know that length. Now, first of all, some students might do this. They might draw a line from D to B like that, and then they have a right triangle. That's a good idea, not bad. But the problem with that is, remember, if this whole length here is 14, and if C is the center of the circle, then that means C is in the middle. I know the length of this line right here would be 7, half of 14. But the problem is I still don't know this side here, and I don't know this side over here, the hypotenuse. So that's probably not the best way to do it. So you got to think outside the box. Maybe I could draw my line like this. Now, Mr. Earhart, how would that help? Well, I'm glad that you asked. Thanks for asking. I know the length of this line from E to F is 10. And I know that D has to be in the middle of this line because D is perpendicular. This line right here is perpendicular to AB, which means it goes straight up because EF is parallel to AB. So we know these two lines are parallel. And if this line goes from the center straight up, and it has to be perpendicular up here, so I know D also has to be in the middle of EF. So if this whole line is 10, I now know that DF is 5. So I know from here to here is 5. And I know I'm trying to find this length right here. We're going to call that X. I'm trying to find this length. But you don't know this length. Yeah, you do. Remember what I told you way back in this problem over here? I said, don't forget the little things. All radii are congruent. In other words, if this is a radius here and this is a radius here, all the radii in this circle are going to be the same. Well, it's the same thing over here. Look at this. Isn't CB a radius? Yes, it is. It goes from the center to the edge. Well, isn't CF a radius? Yes, it is. It goes from the center to the edge. Now, what is the whole diameter of this circle? 14. So what is the radius of this circle? Half of 14, 7. So all of my radii are going to be 7. So I do know the length of CF. It's a radius, and it has a length of 7. Now, if I'm taking this test on the ACT, I like to give myself a lot of space. I'm going to draw that right triangle draw it a little better. Now I'm going to draw that right triangle right over here, and I'm going to make it a lot bigger so I can see it. So I'm going to call this a length of 5. I'm going to call this a length of 7, this a length of X, and oh my goodness, I've got a right triangle, and I know two sides. Y'all heard of Pythagorean's theorem? L squared plus L squared equals H squared, or A squared plus B squared equals C squared. So one of my legs is 5 squared. My other leg is X squared. My hypotenuse is 7, so 7 squared. So I have 25 plus X squared equals 49. Now bring your 25 over and make it a negative 25, and when you do that, you're left with X squared equals 24. 24. Bring the 25 over and make it a negative 25, and you will get 24. But now I don't want to know what X squared is. I want to know what X is. So I must take the square root of X squared. If I take the square root of X squared, I get X. But if I take the square root of one side, I must take the square root of the other side, in which I would get this. Now, usually you put plus minus. In this case, we're not going to, because we're dealing with length, and length is never negative. So my answer is the square root of 24. So I'm taking the AC test. I'm proud of myself. I'm pumped. I figured it out, and I come over here and the answer is not here. Well, don't forget, you got to simplify square roots, okay? You would not want to write 3 times 8 for 24 because you do not know the square root of 3 and you do not know the square root of 8. However, hold on a second, I could write 24 as what? 6 times 4. Now, why would I want to do that? Because I know the square root of 4. And if I know the square root of 4, I can cross it off and put a 2 on the outside because the square root of 4 is 2. So now I'm left with 2 square root of 6, which is your answer right here. A very good problem. Okay, let's move on to number 58. This one's pretty simple. It'll be pretty fast. The entire graph is shown below. One of the following sets is the domain of f. Now please remember this. They're testing your ability here. Let's go back a problem. Over here they were testing your ability to be creative, to know that when two lines are parallel, intersected by a perpendicular line like this, then inside of a circle, then we understand that if C is the midpoint here, D is the midpoint up here. They wanted you to remember that all radii are congruent. They wanted you to figure out how to draw a right triangle and then use Pythagorean's theorem to solve. Very basic geometry. Now in this problem here, it'd be very important to remember that range deals with the y values, domain deals with the x values. Okay? So don't forget that. So when it says one of the following sets is the domain, it's saying one of these sets is talking about or referring to x values. So you know what? We're going to see what the x values are and we're going to see which one of these answers over here gives a good picture of what x is. Okay, here we go. Well, x starts, here it is. This is the x-axis. It looks like my graph starts at -1. And it covers all the numbers all the way up to 0, but it doesn't include 0. But hold it, when you come up here, it does include 0. So now I continue on, and I get all the way here to 1, and it looks like it does not include 1. Oh, but it does up here. So far so good. We started at -1, and we followed the graph along. All these numbers were part of the graph. And then here it wasn't, but it was up here, so we're good. So all these numbers are part of the graph, and it wasn't here, but it was up here, so we're good. So we continue along. Okay, here, x is undefined, but again, up here it is, so we're okay, so we continue on, and it stops here. So it looks like x has been everything from -1 all the way until I get to 3. Now notice this is an open point, so that means 3 is not included. So that means x x runs all the way from -1 all the way to 3, but it doesn't include 3. So how can I write that, using inequalities or set notation? Well, like this. All of my x's were what? Greater than or equal to -1. Why equal to, Mr. Earhart? Because at -1 right here, it was colored in. Let me get out my eraser and erase all these marks I put and take a look. -1 was defined right here. So x is greater than -1, and it continued on and on and on all the way until we got to 3. And it did not include 3, so I'm going to say x is less than 3. Don't put equal to, it's not equal to 3, it's just less than 3. So the domain for this graph, if you study just the x values, not the y's, because domain deals with the x values, if you study just the x values, you will see x is defined all the way from -1 all the way to 3, but not including 3. And of course, if you try to match that up here, you're going to see this right here, and this x line means the set of x such that x is greater than or equal to -1 and less than 3. So they're testing your ability here to remember what domain and range means, and then how to read a graph and how to look at a graph and understand what the domain is. Number 59. Okay, let the values of real numbers a, b, and c be restricted by these two conditions right here. Which of the following inequalities expresses the same relationship between A and C as given by the two conditions? Now remember, you can write equations, you can write inequalities, you can make substitutions, etc., etc., etc. So I'm going to do here what I did way back here on the very first problem we did. I'm just going to write down what I know and just kind of see what happens. That's the best thing to do in some of these problems. So number one, A is 5 less than B. So A is means equals in math terms, so A equals, and if is means equals, then I have 5 less than B, so B minus 5. Now, condition number 2, B is at least, so B is at least for sure 3 more than C. Three more than C. And I'm not sure what I hit there. I apologize. Hold on one second. Okay, sorry about that. One of my boys walked in the room and I was trying to answer a question for him. Okay, so I'm back here. Here we go. Let's review very quickly. So A equals 5 less than B, or B minus 5. And then B is at least, so B is greater than or equal to, it's at least 3 more than C. So C plus 3 more than C. Now, all that I did is I took these two expressions, and you learn, boy, we did this in pre-algebra, okay, when I used to teach pre-algebra and algebra 1. It's simply taking an English expression and writing it in an algebra expression. Now you're seeing why it's so important that you learned that years ago, okay? All right, now, look at your answers. Let your answers help you. Notice all of your answers have only A's and C's. There's no B's in any of your answers at all. So if there's no B's, then I definitely don't want any B's over here. So somehow I want to make a substitution so that my B is gone. Now here's what I'm thinking. Follow my reasoning carefully. I really want to keep this one because is it not true that all of my answers over here are inequalities? Sure they are. So I know I want to keep this. So somehow I got to get rid of this B and somehow get an A in here. So I had a thought, and here's what I'm thinking. If I take this top equation here, and I just very simply bring this -5 over to the other side, so bring this -5 over, and when I do it becomes a +5, I would be left with A plus 5 equals B. Now that's huge, because now what can I put for B down here in this equation? B equals A plus 5. So for B right here, I'm going to put A plus 5 greater than or equal to C plus 3. Now I've got an entire inequality that has only A's and C's. And look at this. Now if I can get A by itself, maybe this will match one of these over here. So bring your +5 over, and it becomes a -5, and it's gone now. So I'm left with A is greater than or equal to C minus 2, because -3 plus a +3 minus 5 is -2, and that would be this answer right here. So letter A. So which of the following inequalities expresses the same relationship as these two up here? This one right here. I simply wrote the two relationships they gave me right here, only with an equation and an inequality, and then I isolated a variable, made a substitution, and simplified. So they're just testing your ability again to go from an English expression to a algebraic expression, and then to manipulate and make substitutions and simplify, which again is really basic pre-algebra and algebra 1. Okay? Wow. Well, last one and we're finally done. So here we go. This is a really tough one. And I really don't have a lot of suggestions for you except to simply say a good portion of you will probably get lost. No offense by that. Some of you will get it, but hopefully my explanation will help a little bit, okay? All right, let m and n be non-zero real numbers such that 2 to the n plus 1 power equals 2m. Which of the following is an expression for 2 to the n plus 3 in terms of m? Now, here's what I'm going to try to do, okay? I'm going to start off with this equation they gave me right here. Actually, well, I'll go ahead and do that. So 2n plus 1 equals 2m. Now, let me give you a little idea of what I'm trying to do, okay? If I want to write 2 to the n plus 3 in terms of m, then somehow over here, I'm trying to get this left side to look like 2 to the n plus 3 power. Somehow I've got to do that. So we're going to have to go back to basic multiplying like bases properties. For example, remember way back a long time ago you learned that x squared times x to the third did not equal x to the sixth, it equals x to the fifth. You learned that whenever you're multiplying like bases, you add the exponents. Remember that? Hopefully you remember that. So if real quick here, let's pretend instead of having a 3 with this x, I had an n, x to the n. Okay, no big deal. When multiplying like bases, you write the base and you add your exponents, so 2 plus n. So do you see how x to the 2 plus n power could be broken down into x squared times x to the n? Hopefully you see that okay. And that's where I might lose a lot of you, but x squared times x to the n is x to the 2 plus n. So I can go backwards. If I have x to the 2 plus n, I could break it down like this. So using this property right here, I'm going to apply that up here. If I have 2 to the n plus 1 power, I could really say 2 to the n power times 2 to the 1 power. Now, remember, my goal is to get this right here. My goal is to get 2 to the n plus 3 power. That really is my goal, okay? And so if somehow I could do that, well, I think I know of a way to do it. Remember, you can multiply an equation by anything as long as you do it to both sides. So if I have 2 to the n power times 2 to the 1 power, now watch, if I multiply by 2 squared, now, I'll tell you why I did that in a second. If I multiplied this side by 2 squared, then I could also multiply this side by 2 squared. Could I not? Sure, I could. Now, why would I do this? Oh, students, think about it. Look at my base over here. I have 2 times 2 times 2. Am I multiplying like bases? Yes, I am. So if I'm multiplying like bases, I write the base once, and then what do you do to your exponents? You add them. So if I have n plus 1 plus 2, that would be n plus 3. So I did it. I took this starting left side and I did some manipulations until I got it down to look like this, which is really what I wanted to do. And if you're asking why, I will show you why in a second. Now, let's simplify this side. I have 2m times 2 squared. Well, that's the same thing as 2m times what? 4? I mean, what is 2 times 2? 4. And now what is 2m times 4? Well, students, you should know 2m times 4, that's not going to work. 2m times 4 would be 8m. Sure, but think about it. 2m times 4, 8m. So, I did it. They wanted me to write, here's what it says, which one of the expressions, or write an expression for this so that it's in terms of m. I did it. I have 2 to the n plus 3 power equals this expression here, and this expression is in terms of what? Is it not in terms of m? Sure it is. So 2 to the n plus 3 power equals 8m. So these two expressions are equal. This equals this. And so what is 2 to the n plus 3 power written in terms of m? Well, it's 8m. Letter K. Now that's a tough one. I'm going to tell you something. They were testing you here on your exponential properties, multiplying like bases, going forward and backwards. They were testing your ability to take a function and write it in terms of another variable, which is very difficult to do, but very helpful. And then, of course, they were working on your simplifying abilities also. So that's it. These are the 60 problems. I hope these videos have been a help to you. And let me close in saying this. You need to be, not just watching these videos, but making notes to yourself where you're weak and study these areas. And you need to realize there are some problems on the ACT you're going to skip, and you're going to just come back to later, or just guess if you have to. On the ACT, it does not hurt you to miss a problem. And so on some of the problems, you will want to guess and just go on. But if you can just glean, 4, 5, 6, 8, 9, 10 principles from these videos, it might help your score go up 3, 4, 5, 6 points, okay? Which is actually quite a bit. All right, I hope this has been a help to you, and that is the end of these videos.